So let's have a look. So the random variable x has a discrete uniform distribution and takes values 1, 2, 3, and 4. Now, before we do even a probability distribution, I want to take a pause there and realize what does it mean by discrete. So if something is a discrete uniform, and because it's uniform, this means that each of these values have an equal probability. So because you've got 4 things, that means all 4 of them are going to have a probability of 1/4 each, because they're all equal, because they're all uniform. That's the key word there. So of course, before this, so make a nice table 1, 2, 3, 4 and write the following probabilities of a quarter. Now let's do the questions. So find firstly part A, the cumulative value at point 3, f3, where fx is the cumulative distribution function of x. So this means for f3, it means you're going to accumulate all the properties up until point 3. So quarter plus quarter plus quarter, meaning it's going to be 3/4. This next one's easy, the expected value. So expected value just means that you're going to take the sum of each of the product of these probabilities. So you can do 1 times a quarter plus 2 times a quarter and so on all the way up to 4 times a quarter. So I did it here. So 1 times a quarter and so on. And you should get 2.5. Now to find the variance, first things first, we need to find the second moment, because the general variance equation is a bit like this. It's actually, let me find some space. It's ex squared minus the mean squared, yeah? So this is the second moment minus the mean squared, and we find this one from part B. So let's calculate ex squared and then see if we get the variance. So the ex squared is like this. Instead of x, we need an x squared value. So we need to make it like an extra table. Call it x squared. Square each of these values. So you have 1 squared, 2 squared, 3 squared, and 4 squared. And now we just multiply this against the probability. So you can have 1 squared times a quarter plus 2 squared times a quarter, all the way up to 4 squared times a quarter. And evaluating this, 7.5. So therefore the variance is going to be the second moment minus the mean squared, and boom, 7.5 minus the mean squared, 2.5 squared, is 5/4. Alright, nice. So that's easy. Now guys, so let's read next one. So the random variable y has a discrete uniform distribution. So like the first statement is the same, so it means all these values have equal probability. So what I would do, so where k is a constant, so write down the probability of y equal y, for y being 3 plus k, and so on. Now like I said before, this is uniform distribution. So this means everything has equal probability, meaning they're all a quarter each. So but what I would personally do is write this as a table. I would call this one y and probability y. I'll list down all the values of y, so it could be 3 plus k, and so on, and write a quarter for each one. Usually this is really helpful for so at least many parts of the questions. Now, where are we? So D. So write down. Okay. So D. Write down. Okay, we've done that. So the relationship between x and y may be written in the form y equals kx plus c, where c is a constant. Okay. So find the variance of y in terms of k. Now to calculate the variance, we're given the y equation. So essentially, you could just find the variance of this expanded form. So variance of kx plus c. Well, I'm starting a lot today. So expanding this out, using the variance property, when you have a term next to the x, you pull it out when you square it. So you have k squared times variance x. When you have a constant on its own, the variance of a constant is 0. The reason why is because the spread of a fixed number is nothing, because you can't have a spread of something that is fixed. Only something that is random, like x, because x can take many values. So that's 0. So then you just write k squared times var x. Var x we calculate as 5/4, so it's essentially going to be 5/4 times k squared, and there it is. Now last step, and we're almost done. F. So express c in terms of k. Okay, so in this case, you could do 2 ways. You could pretty much take the variance of all of these, by in other words taking the mean of everything, and then the second moment, and then equating it to this solution to find and make c the subject. Or you can make your life much easier and just realize that these two distributions x and y are related, because it tells you the relationship between x and y can be written in this form. So what I did here, and this one took me a while, I'm not gonna lie, I was a bit confused. I said when x equals 1, y equals 3, because I noticed that there seems to be some sort of arithmetic pattern here. So this is kind of weird to be put in a question in this S1 paper. X values are going up in 1s, y values are going up in k's. So when x is 1, y is 3. So I plugged this into this equation, and then somehow I got c equals 3 minus k. I did the same using x equals 2, and that represents, and since that goes over 1 unit, this must go up by k units. So I plugged this in, and again, I got 3 minus k. So yeah, I mean, and to be honest, when I look at it this way, it does seem logical that that is pretty much the statement that needs to be done. But anyway, guys, I hope this helped, and let me know if you've got any questions. Otherwise, I shall see you soon. Ciao.